So very good morning, all of you. Um, First of all, I welcome all the participants and I welcome Dr. Zhang to deliver the Teaching Learning Center and lecture series 7th of TLC Talk. And he's going to present his talk on AI facilitated cross-cultural problem solving in calculus. And before the talk, let me introduce Dr. Zhang to forum. Currently is an assistant professor at the Sichuan University, Pittsburgh Institute. Previously, he was at Miami University as visiting faculty during 2018 and 2021. He has completed his MS Mathematics and a PhD at the University of Nebraska, Lincoln, USA. He has published more than 25 research articles and delivered several invited talks in various conferences and seminars. He has obtained many research grants and he has completed one research grant as a principal investigator. He also very much interested to work with collaboration in researchers, those who are in applied and pure mathematics, and is very much interested to do research in data science. Currently, is working on data science. And while visiting Chengdu, actually, I would like to explain just a few minutes or something. Through one of the faculty at the Chengdu University, I happened to meet Dr. Zheng, and he has spent complete 2 days with me. And it was a very wonderful experience for me. And at the time I spoke to him, I requested him to deliver a talk at our university, and I explained our university functionality and our university vision. Everything I explained. He is very much impressed with us. So he accepted our invitation. Actually, this title itself, talk of title itself, it is very appealing and very interesting. And I hope our faculty members will get benefited at the end of the talk. Now, with this brief introduction, let me introduce Dr. Zhang to the forum. Welcome, Dr. Zhang.
Okay, good morning, everyone. Thank you again very much for the very nice and friendly introduction from Dr. Dian. I call him Dian. We know each other, like he said, introduced in a very, I think I'm very lucky to know him. He's a very great professor, and also Dr. Naren, a very kind invitation for me to give this talk. I also saw some of your presentations from the YouTube channel, and I think I'm very honored, really honored to be here to give a talk, because those speakers, I think they have done much more extensive teaching than myself, have a much longer experience than myself. So I will try to share some my personal experience, teaching learning experiments, and some recent research I did in terms of education. So hopefully we can get, as Dr. Nair mentioned earlier, we can get a continued collaboration. I'm very excited to collaborate with you. Okay, so this is my title, but I will actually first show you a few slides about what I normally do in everyday teaching at my own institute, because I think maybe you don't know me, many of you, so maybe get some idea about what type of teaching I like and method I use, and so on. So this will provide some motivation, for the recent education research I did. I think that is shown in the abstract and also the talk. Okay. So this is basically, I just want to show what roughly I'm teaching at the institute, give you some idea about my teaching style and the methods, roughly. And here I'm just saying, we use Blackboard system for teaching, not only online but also offline. And I have a lot of folders built here for the teaching material, like post the PPT, in the lecture notes folder, and then give a homework or project and exam, things like that. So if people use that in your teaching, I don't know in India if you use that, or in your institute you use this, maybe something similar. This is one of my course in linear algebra. I use this just to also to save a lot of teaching materials. Okay, so for example, here's the I give for the project. These are my some of the documents. I give the instruction for what the project should do, students should do, and then give them some suggested topic. And I want to show you some student example later on. These are more exciting to see. And here's the schedule from the project. This is one of the class I taught before. So students give some group presentations, and this is the on the left you can see the schedule. I made it here, and then on the right is the how we evaluate their presentation. So this is basically what I do, the document for the project just as the example. And so in terms of actual class teaching, I'm not doing anything really totally, very, very different from many other teachers, I suppose. But this is just to show you, when we teach mathematics in particular, like this is the example of linear algebra. I use the PPT. In the US, when I taught mathematics, I usually write the things on the board. But since I came back to China, at this institute, we usually do the lecture using the PPT. But my PPT is I take the content from the textbook, but not just copy everything from the book, but try to put the things in some highlight some key points. And the way I'm teaching is maybe you can see a little bit here. I write over the slides so to explain what the definition means or what the theorems actually explains, and give them proof ideas, things like that. So this is because I'm using the iPad for teaching. There's something called the good notes. It's very convenient to zoom in like this. You can zoom in, make the words larger, and you can use different colors, or you can use laser to highlight the key points. So I found this very convenient. So I just want to show you some technology. Maybe I suppose many of you do the similar thing too. But this is just to show you with this technology now we are also maybe can make a teaching more easier in some sense. Okay. Another thing about my teaching, I just sometimes besides the lecture, I also pose the problem. Maybe students can discuss with their peers, or maybe discuss as a group, and then students evaluate their own work. But so my teaching is mostly like like this. I like the students to talk among themselves and be in charge of their learning. Not just I'm doing all the explaining and delivery all the content, but let the students actually talk among themselves and ask more questions. So I try to not interfere too much, only interfere when it's necessary, give them more chance to speak up. So this is basically my way of teaching. And the other thing I want to mention here, because it's connected to the later my research talk to you today, is about also in general my teaching is like I like to give in class I like to show the examples from the not just the example that offered from the textbook, but maybe pick some exercise or problem from the back of the chapter, the book, show them as examples. So that will help students to solve the problem, problem solving. And I also like to introduce the relevant math history, because for me this is also very interesting aspect of learning math. For example, in this page you can see I'm showing a Cayley-Hamilton theorem from linear algebra class. There are different mathematicians, contribute to the theorem, and I like to do this, and also students can say, math is real. It's not just the dry, math content, but actually the math is also invented or discovered by humans just like us, and that way I also provide them some more concrete ideas about a project, because students later will have to do some project. I like to use this opportunity also to give them some project ideas. Okay, so here are some examples from my students. I like to show them to you. For example, this one is one project. Students actually they interviewed the other math professors, so they come up with some questions and topics they are interested, like this Cayley-Hamilton theorem. So they ask a different question to the professor, and then they make the video. I think it's a very good project. And this one is the student actually interview, their physics professor or engineer professor for some application, maybe application in, mechanical engineer, because they are study mechanical engineer, so this is the one example. And this one is very creative. I found very impressive. Students actually, they play different mathematicians. One is the Japanese mathematician SCUPI, and the other is everybody knows the Leibniz, from Germany. Of course, these mathematicians, they live in different time, but the students, then when they play these characters, mathematicians, they actually have to go in deeper to find out more about the, how this mathematician actually contribute to the math, right? To the relevant maybe linear algebra content. So I think this is a very good way, and it's very creative, from the learning perspective. And even more, some students actually, they like to make some mini films. So they write their own script. I put the script on the right corner here a little bit. Actually, they play the character. This one is an example of it's called the discovery of Cramer's rule, in linear algebra class. So students play the mathematician, like a Cramer, and then they just showing a few in a movie style. Actually, they just made the film, with no cost, because they are just play the characters, and then the place is taken in our university. So I found this also very good. And this is something similar. They also make some play. And this one is like a cartoon. Students use cartoon to like the piggy, the piggy here, and this popular cartoon, even among the kids. And they try to explain some difficult concept like Markov chains. And you can actually maybe see a little bit of students actually, they play themselves, and day 1, day 2, day 3, and try to show how they getting more sleepy or wake up, like by this simple examples. I think make learning more enjoyable. I think this is also a good project in that aspect. And the other example I want to show you is the student, they sometimes they really interested also in the math history, perhaps because in my lecture, I often do that, introduce the history to them. So they also try to dig more, deeper into this kind of thing. So they try to find more resource about the math history. To be honest, some of the things I really don't know myself. And when students actually do this kind of a project, and they ask me more questions, that actually make me more also learn something new. So I found that is very rewarding. On the right hand side is actually the WeChat conversation. It's in Chinese, but I just want to show you a little bit. The student actually talk with me. After the class, even with many questions, and I try to help them. I think this is a very good way of learning as well. Not just learning in the class, but they learn more like a research student, like they learn outside the class about what they are actually interested. So I think that's really an example of active learning, and also with this project-based learning. And this is something, I just want to show you is also because we have a TA, teaching assistant for our classes, and I sometimes also make a WeChat group, because in the WeChat you can make a group and talking with my TAs. So this is the group of I had with my TA, and I just send them some videos, sometimes some not just videos, some information about the relevant material with the course, like linear algebra. Everything I found is very useful and good content. I will deliver to the TA, and then the TA will send this content, share the content to my students, because they also have some QQ group outside the class. So this is a very typical like a communication setup in our institute. But what I use from here is that I just like to send them information whenever I think is appropriate. I think this is also benefit for them to get some ideas, also for me to keep up with the learning. And this is the time when we have ChatGPT come out. I also show them some information. So this is the one thing I want to just say, that I haven't really made it happen, but this was on my wish list. I hope to, because I found this text, this is not textbook, but this is one of the book written by a Japanese, maybe a mathematician, about the very simple introduction to linear algebra. This is the cover of the book. I don't know if this book has a English version or not, but this has a Chinese version, and it's basically a cartoon book, but it's about learning a lot of stories about learning linear algebra, and they do introduce a very good content about the linear algebra. And I think the book is very easy to read because even high school students can understand the content. So I was thinking maybe students can use this textbook, can use this cartoon book as a base. Try to use some AI tools if possible, like ChatGPT, or at that time there's something called the Made Journey. I guess now there may be more better tools. Maybe combined with some software if they like. Doing some maybe geometry. Like for example, GeoGebra, because they do linear transformation. For example, this is the example shown here, and so I wanted maybe students to create their own book like this. So maybe this is something we can collaborate later on. I feel like, because maybe you have some good textbook or good books written like this in India, and then maybe we can compare those books and then try to make something let the students to actually work. I think this is a very just my idea, but I think I really wish to make it happen sometime, because I think the students are really have a lot of good ideas, and some are not myself can actually imagine or can do. So it should be a group effort. Okay, I think at this juncture is basically first part of my talk, just to give you some idea very quickly, roughly about the how generally I teach, and maybe some I think myself as some maybe so-called creative, but maybe not so creative, teaching things, teaching points. So I think this is the prepare for my next part to deliver to you, which is on the talk today, is about my recent collaboration with my two of my friends, also colleagues. One is the Professor Todd Edwards. He is on the top here. He's in the math education at Miami University, so I know him also a long time ago, and he's a very good my model, one of my role model to work in math education. And down here is the tutor. He's also a math instructor at that time, and he also interested not only in mathematics and math education. He had the math education master degree, but he also interested in machine learning, and he's knowing more practical machine learning, I think, than I do. So I think it's a very good collaboration we actually did here. So basically, this is the idea. So we were around the time of 2023 when the ChatGPT, just I think came about. I think ChatGPT maybe 3.5 just came about not very long ago. And I was talking with Todd in the US. So we thought maybe we should try to do something new. Something new maybe means that we can incorporate some of these advanced tools, new AI tools into our teaching. But Todd really not teaching any calculus to the university students, but the tutor, he introduced me the tutor. Tutor actually that time he's teaching the pre-calculus students in the US. And I was teaching that time the calculus class, two section of calculus class to freshman students. So we thought we should get together, talk about some possibility, to work together, and which is using AI, AI technology, and to help students to understand some key concepts of fundamental ideas of calculus. So this is basically what our initially what we thought. Is very maybe fuzzy at first, but then we started talking, and here is some example. Before I show you more, I think maybe many of you, I'm sure you are maybe familiar now what the ChatGPT is. It is now is actually maybe a more advanced version, but that time we have a ChatGPT 3.5. So on the right, I put the figure, just like to just show you what do they do. Like on the top, you can ask a question, maybe ask some question like a math question. give some function like, okay, can we find a function whose derivative is x squared? Is that right? Ask this question. So ChatGPT will have some answer to you, tell you whether it's right or not, or give you more explanation. And if you have more questions, you can keep asking. Just like more like a dialogue, just like a conversation. So it's I think it's very friendly in some sense than many other, computer technology we used before. So this is what we use. Actually, we try to embed this AI. We call it AI agent, call this GPT. So try to embed this as some participant to our project, so students can actually interact with that, because everybody can talk, everybody can ask questions, right? So we can embed this. But of course, we have to know what we want to embed to our topic. Okay, so basically, this is what you can say now, the setup. So we actually think about this because in the beginning, it wasn't very clear, we teach a large class, like I have 60 students in my calculus class. Tutor has maybe about the same number of students, like roughly 60 students. So we cannot actually use all the students, although that would be very good for the data. But the problem is that, in the US, because he's teaching the San Francisco State University in the USA, the problem is that if you do a research like this, you have to get approved with IRB. So this IRB is you cannot just take all the students. Maybe for your research, you have to get approved. It's not a very easy or very quick process to get approved. So actually, tutor wrote in the IRB, we just get total 4 students, which means that from my class, I have to choose 2 students, and from his class, he has to choose 2 students. So we ended up at only total 4 students, which is a very small, very, very small sample size. But it turns out for a case study, so there's a educational research method called a case study. So for case study, is okay. It's a standard, have a small sample size. So this is what we end up. So we actually chose 4 students. Actually, all the students they are female at the end. And so basically, we meet on the Zoom, just like right now I'm talking with you on the Zoom, because 2 students are from the US, 2 students are from China. And not only that, they have to work on some math problem, which I will show you very soon. And they have to, work with problem basically by themselves. The teachers, including me and Todd and the tutor, we will not interfere, but the students will, interact with the AI agent, which I'm also going to show you more. They're going to interact and with AI to collaborate on solving math problems. So this is basically the setup, as you can see. So our main research question is what? Well, we are trying to say that if we give them some task, mathematical task, which is coming from calculus and precalculus. So how do this AI enhance the task? Because we will embed AI into the task. So how do this task will impact the students' understanding? In particular, the conceptual understanding. And because the students also come from different cultural background, they are not just only Chinese students. They are maybe American students, or maybe even come from other country background. So how does that impact their culture awareness? And also they work together, right? So there's a collaboration going on. So how does that impact on the collaborative problem solving in this context? So this is boils down to this research question we are trying to answer. Okay, so let me talk about the activity, because this is the main part actually, because after all we have limited time, right? That time we had only going on in the semester. The semester will not stop just because we are doing this research project. So me and the tutor, we are actually teaching in different places. So our courses are also different. He's doing precalculus, I'm doing calculus. And if we want to decide on some common task, we really have to think about what would be the good activity. So initially we thought, maybe we don't give too long, too many tasks or very difficult tasks or things like that, because we also have to think about how to incorporate, both classes, because 2 students from precalculus, right? They haven't learned calculus, and the 2 students are from calculus. actually they are in China. Their background is also different. Learning, their knowledge, everything is different. So we have to also consider a lot of things like that. And what kind of a task will be appropriate, will be good also for our research question. So actually Todd suggests initially maybe we make 3 different kind of problem. So one problem is like more straightforward computational problem, computational task, which everybody means here for these students, they can easily get started and talk to each other and work out. This is the first one, computational task. And then maybe we want to get some more applied problem where there's an applied situation, so students can learn the concept, that way. And then there's a more conceptual oriented problem. The concept will be actually very important for both calculus and pre-calculus. But this is maybe also more challenging because it requires students have a better, deeper understanding for the content. So basically, that was our initial thought. We make this kind of a 3 activity. So let me show you some exact problem we actually made in the first time. Oh, by the way, our research plan was to do 3 weeks. So that means 3 Zoom meetings. Each Zoom meeting will have a student to meet with each other about 1 hour. 1 hour, okay? So this is like maybe we think maybe one of the meeting will do this activity. So the first problem, computation problem, as you can see here, this is should be very simple, just giving a quadratic function and ask them, to get some maybe a slope of at the 2 points on the parabola. The students can actually get hands-on, with the graph and to do that. Even pre-calculus students, they have learned about the necessary algebra, to do the work. And for the applied problem, we also pick some very, I would say, very standard problem, even a textbook problem like this called the fenced vegetable garden problem, where you have this, tell you have how many 1,000 feet of fencing, for example, to make a rectangular garden, right? What the dimensions are like a height and width, right? So you would make to maximize the area of the garden. So something like that. But we want the students to actually give the detailed solution, including, some hand-drawn graph or, maybe if they use some AI tools, they should explain. So that time, this is when we made this task, that time we haven't really specified exactly what is the AI we want them to use. Although we mentioned, like a calculus agent, but we did not really, we did not actually put enough to it. I will show you the detail later, okay? But this is roughly what we made at the first. And then for the conceptual question, we make something like this, which is connect to the previous problem, like the one with the garden problem. We just want them to actually explain how they use the slope of a secant line to determine the maximum area. So we did not mention in particular the concept of a derivative, but this is embedded into the the problem. Even the pre-calculus students, where they haven't maybe really learned the derivative, they could, by solving the problem or collaboration with the calculus students, they may we hope they may discover the concept along the way, and they can also use AI tools as much as they need. So this is basically we have set it up from the beginning. And what data do we collect? Well, actually we have a pretty, I think, rich and very detailed data, because in our Zoom meeting we actually record everything. We have the video and we have audio, and then the students, they have a work on the worksheet we provided them. So they actually we actually collect their written work for the task. And of course, the students will interact with the AI assistant. Sorry, I haven't shown you AI assistant, but this is actually already we used for this task. And they have a conversation with AI assistant. This is also very important for us, because we want to know how the AI enhanced task impact those things. So this is one of the important data we need to collect. And beyond that, we actually collect some surveys. The surveys like not only after the meeting we ask some feedback, but also within each meeting. Because total we have 3 meetings. So within each meeting, we also at the end of their work, students' work, we also come back. Our instructor, means me and Todd and Chengdu, 3 of us, will talk to the students about 15 to 20 minutes, just to debrief what they have learned and what are the difficult things, and maybe they have some problem with AI, stuff like that. So this is also the data we collect about the surveys. So we have some idea about their interactions and their mathematical learning. So I want to, again, give you a little bit more. Maybe I should say this a little bit earlier, but at this time, this is so we had this 2 meetings. We basically distributed the content. So the first meeting, we just let them to talk to each other, because the students from each side, they don't know each other. Actually, not that they may not, they definitely don't know each other, never seen each other before, just suddenly see each other. So we don't want them to just get into the mathematics right away. So we want them to actually talk a little bit, because one has to keep in mind, my students from China, their English is not their native language, right? So when they talk to some new friends, maybe from the other world, they have to also speak English, not in Chinese. So we want to provide them some low stress context to get know each other better. So this is some called icebreaker activities. So this actually became our first meeting. It turns out we did not do any mathematical work. So the second meeting, as I just showed you those activities, it became actually the second meeting, which we call it derivative or optimization, because we have this applied problem where you have to maximize the garden area. So this one, actually, they started to work on the worksheet and use a little bit of AI. So as you can imagine, maybe the AI wasn't really used too much, right? Because of the content wasn't really that difficult. It turns out that's exactly what the students wrote in the feedback, or they told us, orally. One student said, they did not get much, needed to use AI. Even the pre-calculus students, they both claim that, the problem is not challenging. It's very easy to solve. They could just solve the problem. Even for calculus students, they can solve the problem in their head. It's really not difficult, just finding the slope of the secant line. They know the formula, they can do the computation by hand. It's not difficult. So there's not much of using AI. And the other students from the US also suggest that, maybe they want to say more a little bit, in the next meeting, because there's a third meeting we planned for. So they want to say some more about, maybe how the Chinese and American will solve math problem differently. So they actually bring us this kind of a suggestion. So that actually lead us to think a little bit more carefully and deeply about what should we do for the third meeting. Okay, so the third meeting actually is very important for the whole research right now. I'm talking to you right now because really after the second meeting, we talk to the students and we reflect on ourselves. Maybe we have to modify our task. And not only that, we maybe also should think deeply about what is really the AI, right? But the AI, we should make it more maybe useful in some sense. So with those considerations in mind, we did not have too much time, because all the time is very short. We only have 3 weeks, and these are all consecutive weeks. So we have to come up with something very quickly, and something maybe also very meaningful for our research purpose. So eventually we come up with 3 kind of questions. So one question involves this problem, which is we want the student to find the area, under the curve, but not just finding the area under the curve, but actually we want the student to search, maybe this is using the AI to help to search how the people, mathematicians in particular, in the ancient time, how they solve this problem, like mathematician living in the 16th or 17th century, like Newton, for example, how they solve the problem. And one problem I also actually, I say because Todd was asking me to think about this problem better, better problem, because I was teaching the calculus and the tutor was teaching the pre-calculus. So I was thinking maybe how about this open-ended problem, like finding the exact value of the area, under the graph. But this exact area we actually may not be able to find. So this is like, for calculus students, they is even maybe open-ended, because they usually find some exact area by the formula, by the fundamental theorem of calculus. But for the pre-calculus students, maybe that's also very interesting to think about. So I think that may be a good open-ended problem. And on top of that, they can use AI to actually help them, or whatever AI tools they come up to use. And eventually, we also said, okay, maybe because the students come from different backgrounds, different majors, so why don't we just ask them to provide some real world application instead of we give them some ready-made problem, for the application, so related to their majors. So that's basically the problem, the new task that we try to give them for the third week. So this is actually is the central thing for the whole research eventually. And I will show you the detail, the task. So now this is the part one, right? We have this first more straightforward, we call the get started feature from the AI agent. So students can just use that. And the second one, as you can see, part 1B is the one I just talked to you about, is for the using the math history, right? Going to more math history, because you have to search for the mathematician. So one from the West, one from East, not any mathematician, but one from the West, one from the East. So provided some relevant. So they can use something called the talk to a mathematician feature from the AI agent, which I'm going to show you in a second. So here's actually the AI agent looks like. There are three different buttons students can click. One is called the get started with integrals. The second one is like a talk to a mathematician. So once students see the problem, they can click on this button to talk with the ChatGPT, ask what the mathematician they can give to them. And the third one is the create example where the, finding the exact error is not even possible. So basically, this is the how the AI can be used. For example, when students select the talk to a mathematician, you can see there are 5 mathematicians are listed here, right? So number 1 is Newton, and number 2 is Leibniz, and number 3 is SCUPI. So there are some mathematicians from the West and some mathematicians from the East. And some mathematicians are actually male, some mathematicians are female. So students can choose their, by their own choice. And if they want to choose, for example, Emily Noether, like number 4, they can tell the GPT, tell them more about how Emily Noether may contribute to this problem of finding the error under the curve. So basically, this is what we made it more, for the AI agent. And this is actually for example, students select Newton. Okay, so the ChatGPT will actually give some suggestions or ideas for how the Newton may solve the error. Okay, but maybe it's the information they provided is not enough, so students have to do more. Okay, and okay, sorry, I'm using the PDF now, so this is supposed to be a video, but somehow I cannot show it here. But let me go on to talk a little bit about the maybe the related to our research. So basically, what I just showed you now is about roughly what is this research about. I hope it's clear to you what it's about. But when we start to actually summarize, right, writing the paper, we have to also think about doing some literary review, what other people have done, and then we also have to think about what we have really accomplished with this given the data that we have. So for example, one trend of research is about different kind of collaboration, and these are the coming from the paper by Mueller and other people in 2012. This is pretty old, but this is a very kind of influential in this area. Different kind of collaboration. So one is called the co-construction, one is called the integration, the other is modification. Okay, so for example, the co-construction, as you can see here, we have 2 students. So each is the agent, right? So they just communicate with each other to have the argument. So this is the co-construction. And integration means that one student maybe acts as more like a primary agency, but the other one is like a secondary. So the secondary ones give some interpretation from the first one, where the first one, which is more primary, is more informative to the second one. So this is the kind of a little bit imbalance, but this is called integration. Okay, modification means the first student gives some interpretation to the primary one, but the primary one actually come out with the argument by some modification, because maybe the argument given by the first student is not accurate, or maybe it's just a wrong argument. So this is some way to formalize a little bit about the collaboration. And also people have done some research in the past about like Davis and Simi in 2003, what it means to be a collective mathematical understanding. So he just gave different criteria. Actually, because of time, I think now I'm not going to talk so detail about this, but this is, we basically look through at each of the criteria, like maybe the number one, internal diversity. Students have a range of interest in different expertise and contribute to the group in different ways. So we check these criteria based on our data, like the video we collected, and go through that. We say from the students' dialogue, we just say, okay, are they satisfied or not? So if they are satisfied, we say we have some collective mathematical understanding come out. So there are many research, interested in different aspect of that. I think is relevant to our research. So eventually, we actually come out with our own so-called context responsive pedagogy. So this one I'm not going to give you too much detail because I haven't really put too much information here for the different component. But I think it's just to show you, eventually we have to go into different components like one is the self-determination theory. One is the constructivism. Maybe it's familiar to many of you, like in education. And then the culturally responsive teaching. So the learning is at the center, as you can see. But we also get AI and the mathematical content on the other hand. So this is and also the instructor, of course. So this is altogether, this have some kind of a dynamic framework. So we just name it like a context responsive pedagogy. So I want to spend more time to show you a little bit more, maybe more interesting part about the students' dialogue. What we actually can learn from this research. So, like for example, when students doing the problem, they just have this kind of a dialogue. For example, if you look at the bottom here, the pre-calculus student, the first one said, when we try to find the area under the curve by mathematician, SCUPI, they just say, okay, maybe just add up by dividing the area. So we are not, because the teachers, we are not in the meeting, and we may not even teach them yet, what is the Riemann sum or the procedure. But the students, when they do this problem, they are engaging with themselves and talking with AI. So they learn what method actually the other mathematicians actually did. And this is not even written in the textbook. So I found this dialogue is also very instructive. And here's why I want to show you more with this other task where we ask finding the exact errors maybe not possible to find. Is also very surprising to me, actually. As you can see the dialogue here. So first student just type the create example. So choose from the AI, right? Talk to the GPT. So GPT just not provide the answer, but GPT provide the first step. So GPT said, okay, choose a function. And we need to start by selecting a function whose error is difficult to determine exactly. And then the GPT actually give a question number one. So can you think of a type of function that may be more complex to integrate than a single polynomial trig function? And even provide a hint, consider a function that oscillate rapidly or have a discontinuities. So the students just come up with this example, y equal to 1 over x. So she just input that function there. So GPT respond, great choice, and then give the step 2, defining the interval. So the students just said, okay, this is from the pre-calculus student. She said, I think 0. But the 0 is just one number, it's not the interval. So that when she entered the answer, when she just entered the 0 into the GPT also said, completed the interval. So that is like step 3. And then the student just follow the advice, follow the suggestion, give the interval like maybe from 0 to 2.5, like the interval. And then the GPT also offered the step 4, like understanding the challenge. Like this leads to an improper integral. I don't know if you can see here. So this leads to an improper integral. So improper integral, this concept was not even taught for calculus students at that time. But the students, gradually by solving this problem, coming up with their own example. Of course, coming with some help of the hint from the ChatGPT. But they actually get some concept which is very new to them. In this case, it's called the improper integral. This is something not only pre-calculus students haven't learned it, but the calculus students haven't learned in class. So I'm very surprised. I'm very glad to say the students they do themselves and without the teacher interfere, and by using the AI step by step, they come up this kind of solution. Okay, so I think I will quickly talk about here, because there's still a lot to talk about the background and how we set up the AI assistant, like how the prompt engineer works. But I think I will leave that maybe in the future if there's still a chance to talk about it, because this part also Tutu knows more than me too, because he set up more for the AI agent. But this is a very great work, because it helps us to is essential to us to actually do the research. And I want to summarize a little bit about the implications maybe for you, because the paper we are still writing. So the findings I think I'm gonna refer to you for the paper. So the implications here I think is maybe relevant to us for the seminar, maybe more. So the first one is the pedagogical implication. So I think that by doing this research, I think really foster students' engagement, deeper engagement, and promote active learning. I think there's no doubt about that. And really, I think the students can learn the concept, and create a very inclusive and effective learning environment. Because when the students they talk to each other and engage doing the work with AI, there's not really a much pressure, like they just I say not much pressure, because just the way I perceive from their conversation to each other, and it's gradually the meetings come more and more smooth as it go along, and it really empowers students to take ownership of their learning process. So I put it right here, because there's one thing we have to keep in mind: the integration of AI has to be very carefully put it, because there's still a traditional teaching method and peer collaboration, like a human collaboration. We should not ignore about that. It's not just with AI, because AI is not always perfect. It's not always perfect, and we still have to think more deeply about how to make the AI works better. This is something we have to keep for the future. And the implication for the AI in education is really enable personalized learning experience that is tailored to the unique culture and educational backgrounds for each student. I think that is very important for the diverse classroom, where students are coming from different backgrounds. Everybody is different, as the Dr. Naren told me earlier, to share in the talk, right, how we do the different teaching techniques for the diverse group. And I think that this is with the AI, this has some advantage of that, because the AI can have help, for the human teacher, just to take care of the different learning needs. But on the other hand, I also putting right here. But we should also think more deeply for the educators, or for the mathematicians, or for the math teachers. We should think more about because we need to have because the students they are different, right? If you are teaching a class of 60 students, for example, that's a large group, right? So they have a very different understanding, or different ways to approach the problem, things like that. And the task maybe is more complex, and some learners they are maybe more advanced. So how do we make the AI system to design in a good way, so they can accommodate all kinds of needs? That's also very challenging. And that brings me to the last one for the curriculum design, because this really encourages the educators to move, just beyond the traditional and the one-size-fits-all curriculum model, where I think we are currently still very much in this kind of thing, because we have a syllabus, right? Maybe if 5 teachers teaching the same course, we may have a roughly common syllabus. We have every chapters from the textbook. We know what we are going to teach. But right now, we should also think about more. How do we design, learning experience that responsive to the diverse needs and the background of the students? So, but on the other hand, we should carefully consider the balance between the AI guidance and the traditional instructional methods. because from the time we do the research, we also say that the students is not just they do everything successful. So eventually the instructor will also we have to come. Like the second meeting, we talk to the students, get the feedback. We actually made the task. It's not like everything is made from AI, right? So we have to not forget this AI is not at the current time, at least we are still not totally rely on the AI, because the instructors still play a very crucial role. And we also should make sure that this accessible to the student at different proficiency levels, as I mentioned earlier, and providing necessary scaffolding to bridge gaps in understanding. And we're also offering opportunities for deeper exploration and engagement. Okay, and in summary, a little bit, the limitation and the future research, because based on this particular research we did here, and we still have a very small sample size. That's still a disadvantage maybe, and it's only focused on calculus content, and and also we do the survey, but the survey comes from the self-reported data from the students. So that may introduce some bias, because students may not always accurately reflect their learning experience. And the AI response also limited, because it's not like, as I said, we all know, right? AI is super perfect. It's not like that. So potentially it can be also biased, but it is also based on human inputs all the time. So that is not the perfect. And the technical issues, because we are doing online, with the Zoom meeting, so there may be like online issue, connectivity problem. Like earlier when I mute myself, I did not even know that happened. It's like that. So this is also some propose some challenges that will impact the study outcome, because that when you solve math problem, you are very concentrated. If something like that happens, that maybe stop you thinking very well. So, but anyway, I think at last I want to say that carefully consideration should be given to the AI implementation, because after all, we have already these tools available there, and we should think about how to make it effective and equitable. Okay, thank you very much.
Thank you, Dr. Zheng. Definitely the talk is an excellent one. You have started from Kramer's rule, and how you have done your experiment through the students, and making students for designing play and learning mathematical history, and introduction of math history and mathematician provide a link for the project and all. And at last, towards the end, and given some criteria for valuable collective mathematical understanding and context responsive pedagogy. So this is a new type of pedagogy we come through your talk. And pedagogical implications and implications for AI education and implication for curriculum design, limitations and future research. Definitely your talk is a wonderful one, and you made excellent research in that. And we also would like to join with you to have collaboration, or to have the similar kind of experiment. We also would like to participate with you and your students, with making for the benefit of our faculty and our students. So on behalf of Shastra, once again, let me thank. And before that, there are a few questions. Almost you have answered for all the questions. And there are a few questions from our faculty. So let me ask one by one.
Okay.
Natarajan, he posted a question. Does ChatGPT like AI tools prevent critical thinking of student community? Your comment, please.
Okay, let me say the question. Can you say one more time? Sorry.
Does ChatGPT like
Yes.
AI tools prevent critical thinking of student community?
Does the AI provide a critical thinking? Yeah, that's a very good question. Actually, I'm not an expert of critical thinking, but the way I interpret the critical thinking, like because of mathematics, like Dr. Laren mentioned earlier too, like math is a lot of thinking, right? About the thinking. I think that's true. Math is even difficult, like for maybe a person to study math all the time. It's always difficult. And I think the AI, on the other hand, because in our research, the AI can be two different interpretation. Like one, maybe you can think of just like a ChatGPT kind of AI, and the other is, if you use something like a software, like a Desmos or like graphing tools, maybe that's also AI, right? You can interpret more generally about AI. So I think basically the AI, like ChatGPT, for example, is in some sense is a smart way to communicate with the human, because when we interact with ChatGPT, we just pose our questions and see what comes out, and then after that we decide what we want to. So it's usually called a prompt, right? Give a prompt, we give another prompt, and to see what come out. So I think the critical thinking is in my opinion, is subtle, because because it's not only in the AI, right? Because we human and AI still interact. So I that's my understanding. I'm sorry, I may not answer the question very well, but I'm just saying, like, based on my own understanding of AI, because I feel like AI is just nowadays the technology is still going on, advanced. But the way I'm taking from the ChatGPT is very handy, it's very convenient too. But on the other hand, it's not always how to say, it depends on the person who uses it. Because even we pose the questions, we will get a different response. So in that sense, I think the critical thinking is not generate by itself always, but it's interaction that makes sense.
Okay.
Yeah.
Okay. Thank you. And another question by Dr. Naren, is head of TLC. Have students reported any difficulty in giving appropriate prompt in AI tool? Giving appropriate prompt is key for AI tools to give the appropriate response. Let me.
Yeah. Can you say the first question one more time? Sorry, it's a little bit hard to.
Have students reported any difficulty in
about
giving appropriate prompt in AI tool? Normally, giving appropriate prompt, Normally, giving appropriate tool is appropriate prompt key for AI tools to give you appropriate response.
Oh, you mean the AI tools, right?
Yeah,
you are saying the AI tools. Sorry, can you say one more? I'm still not quite get the question, but I think the question is good. Can you say one more time?
Or just let me ask, have students reported any difficulty in giving appropriate prompt in AI tool?
Oh, how they report the difficulties, right? The difficulties. Yeah, actually, I should mention. Sorry, I was nervous about the time, so I was going too fast. And actually, the tool at that time, the ChatGPT at that time in China is for my students, my side, even myself. We don't have the tools. So when we actually use that for the meeting, for the Zoom meeting, only the US students, they got this. Actually, only one student got the account to use the ChatGPT. So how they do it? Actually, if my students here from China, if they have some question, for example, I don't know how to find this antiderivative, or I don't know how the Rima actually did this integration. So she will actually tell that to the student from the US, and then the US student will actually enter the question, like type the questions into the ChatGPT. So in that sense, I think it's a little bit imbalanced, because it's only one student got the access to the ChatGPT. So I would say that is the one disadvantage. But maybe it's also an advantage, because that makes them to work collaboratively, right? So who knows? I mean, it's not it just happened that way, because not everybody have the ChatGPT available at that time, or the AI tools available. So that's one thing they report is difficult, but it does not cause really a big trouble for them, because whenever they need it, or whenever they need other people to help, they actually work very smoothly, as the way I'm taking from the video. They actually work very good. So if one student don't know how to do it, she can ask her partner, sit next to her, maybe talking Chinese about what actually happened, or what she actually means. And then the other student actually just interpret or translate. And similar happen in the US student, they just talk to each other. and then they just compare with that. So I think for students, they just work very good. Maybe because they are all, I think maybe because of they are all female students, also they are easier to talk. That's my personal opinion. And then on the other hand, I think they are similar age. And I think maybe also from the Chinese student perspective, they think, oh, maybe they are very curious to learn how the American students actually learn mathematics. So they are also very, in that sense, they promote a very positive learning environment, in my opinion. So I think overall, I think a positive is bigger than negative. Yeah.
Okay. Another.
Sorry, I may not answer the question very well. I'm just trying to say what I maybe most come from my own. Yeah.
Okay. Another question by Dr. Hariharan.
Uh-huh.
In calculus,
Yes.
related application problems.
Yes.
AI tools have been used to explore the mathematical concepts through interactive simulations, graphs, and animations. Now the question is, can you suggest any other tool like GeoGebra for simulations?
Yeah, actually, this is another question. Actually, this is not something we go deeper in this research because we try to use ChatGPT for the most part. But I think you are the professor is right, like asking for example, GeoGebra, right? Actually, I don't use much of a GeoGebra in my teaching or anything, but I know this is a good tool. I have seen some use of it, and some people can use it very good. I think one feature good is about is you can set the parameter, right? Like if you have some variable like A, B, like A is the length, B is the height of the rectangle, you can set the parameter A from maybe 1 to 2, B from 2 to 3, like that. And then you can adjust your picture by moving the bar, right? By moving the bar from left to right or upside down. So that way, I think maybe give more direct visualization to the picture, right? So then the students can actually get more experiments. This is just my imagination of if you use this kind of this so-called dynamic geometry software. I think that actually helps to help, especially the students who are more used to or rely on this concrete examples. You know, they can use these tools to help them to get to the specifics of the computations. But for students to learn some abstract mathematical concept, they eventually need to get out of this. I think just rely on this technology, right? They should still to maybe do some traditional way, like write the formula or think about what is the algebra, right? Like how to write the formula by themselves. I think is also a tricky investment. Like if we can't really say which way is better. If you use some technology, maybe technology has good and bad. It's not always just do the thing that you think is just like our research here. We cannot definitely say, oh, AI is definitely improve students' understanding or something like that. We don't know that, right? Because we can only say this suggests maybe it's have a good potential, but we cannot actually say for sure.
Okay. One more question. If we this question posted by Dr. S. Balaji.
Okay.
If we search for a solution for a problem in ChatGPT, most often it gives wrong answers, and we have to verify it every time. How to resolve this in ChatGPT?
So how do we? The question is how do we verify?
His question is every time we posted a problem, ChatGPT giving wrong answers.
Wrong answers. Yes.
The correct answers.
Oh, I see. That's another very good and key question. I think using ChatGPT. Actually, I'm not so sure about the very new version of the ChatGPT now because we were using the older version. Maybe that's still not so great. But I think you are right. It's like if you ask something like in our project here, we when students try to find the mathematician, talk to mathematician, and then they give some output is very long, and many information actually is not very useful too because they just say, oh, this mathematician did the blah blah blah, and using some cutting the rectangle, which is more or less like in the textbook how they explain the Riemann sum. Not exactly. I don't think if if as a teacher, if you say that answer, they will know, okay, this definitely is not something they want, right? But as a student who hasn't really learned about this anyway yet, when they say this answer, maybe it's very difficult to decide if ChatGPT, whatever ChatGPT gives, is actually valuable or not. So I think the question, the professor asked about from the biology is that, if you give the long answer, and I think still this is related to the first question too, like the critical thinking. We really have to have some judgment. We have to make some judgment. We cannot just always rely on the AI. That's all I can say. Because maybe you can talk to your friend, or maybe talk to another expert, like maybe talk to your professor, maybe talk to your student, who's better in performance in the class or something like that. You just have to, as long as you are keep learning. In my opinion, I think that's will be helpful. But my advice would say, not just okay, if it's saying something very long and just say, oh, this is all too much. I can't read it. Especially if you are, for example, if you are English is not your first language, right? Especially I think of my students, they are Chinese students. If they say an answer like that in English, they probably don't even read anything. But if it's in Chinese, if it's that long, they also maybe don't read it, right? So I think the question here is that we should not just simply discard the information. We should still read through, and then find out some useful, from the. But this is really case by case. I think sometimes the answer may be just long by nature, right? You may need receive some answer that is long. You may want to, like if your advisor saying something, maybe he said 3 sentences, which are all very important. You may want to take his advice seriously. But if somebody say 100 sentences, which is maybe not really you care about, you don't think it's useful. I think it's like that. Yeah, you have to. We have to really. I don't think it's an easy answer. You have to judge. You have to judge by not only by your own experience, your knowledge, but also you should also work with AI more, maybe to say. Right now, the AI is developing. Like I'm saying, I'm not also keep up with this very much either. But I think maybe one day the AI will be better at summarizing information or give some good answers. So we don't have to even think too much. But I think the problem right now is we still not there yet, right? Because we still have, even though you have a very good AI, let's say you have very good teacher, but it doesn't mean that teacher will have all the students are as good as that teacher, right? It's like that. I think it's like that. So yeah. Sorry, I may not answer the question very well. I just give my own reflection. Yeah.
The next question is by Dr. M. Sridharan. Actually, this is a question I think everyone will have in our mind. I think he is representing all of us. Will AI replace teachers in the near future? Technology, science, engineering, arts, etc.
Yeah. This is what I'm keep saying here. Actually, this is very hard. All questions are very hard here. I don't know. I even want to hear your opinions. In my opinion, sometimes I feel nervous, sometimes I feel exciting, and sometimes maybe I'm in a bad mood or I'm lazy or something. Maybe I think that, oh, this is good news. I don't have to teach. I can just do something I'm more interested in. Sometimes instead of teaching the same content all over and over again, maybe the AI can take care of that part. Kind of earlier we had this something called flipped classroom, right? Something like that. People just make the video and then the students can watch the video and then the teacher go to the class, just talk about some important stuff, because they expect students have already learned something from watching the video. So kind of like that. I think if the AI can do some part of that and release the the burden of a student understanding, I think as long as AI is going that direction, in my opinion, I think this is still good. This is all I can say. You know, I can't say because I know very little about everything. I think, and I'm not a person to start to go through look at the future too much. Like I think AI may not replace the teacher because because we like I said even in the talk, like a teacher, we will still in charge and know the students' needs, right, and then work with the student. That's our job. And AI is only a tool. Like when you cut the apple, you use a knife or use some maybe better tools to cut the apple, take off the skin. But it's not like we are not there. The apple is still eaten by us. We take only the tools to eat the apple. The AI, the way I look at that is like that. It's getting more and more convenient, but it's not something will replace us, totally. Yeah. So my short answer would be no. But I think maybe my answer is wrong because who knows? Maybe in the future we will not. Will be replaced by the AI. Yeah, we don't know. Yes.
Okay. Thank you. Dear participants, do you have any questions?
Yes, thank you for the questions. Those are all very good questions. Difficult questions.
Okay, Professor Zheng, you have answered for all the questions, and excellent lecture you have given for all of for faculty and
thank you.
Research scholars. Definitely, the talk will be the eye opener for us, and we are thinking, and actually you have simulated certain things in our minds, no doubt at all. And now, before concluding the session, let me thank our Honorable Vice Chancellor, Chancellor, Vice Chancellor, and Dean Planning and Development, our Registrar, for their able support and providing this kind of wonderful platform to all of our faculty, research scholars. Otherwise, we won't get this kind of talk about something. So for that reason, I once again thank our Vice Chancellor, Chancellor, and our Dean Planning and Development, and Head of Teaching Learning Center, Dr. Naren. And I thank all the participants. Actually, Zheng, today is a holiday for us. Though it is holiday, almost we have a good response to all the faculty, and the faculty have responded, and many faculty has posted so many questions, and just I have cut shorted the questions and all. So once again, let me thank all the participants and the management and head TLC, and Sridharan sir, I thank you, and Dr. Zheng, I thank you once again. So,
yes, thank you very much.
We would like to have a fruitful collaboration in future.
Yes, exactly.
Hope we will do.
Yes.
With Sichuan University, Pittsburgh, and Sastra University. So we shall think of that line, and we shall keep in touch. I will send you mail, and we will explore some possible collaboration with the two of our institutions.
Sure. Of course. And I will also, if I have a better answers for those questions, I will also reply more in the email. Yeah. I think I did not answer very well some of them.
You answered.
Yeah. It's difficult to come up with good answers.
Yeah.
Thank you very much.
Thank you, Zheng. Thank you.
Thank you, everybody.
Thank you for all the participants. Thank you.
Thank you.
Have a nice day. Naren, thank you.
Thank you.
Thank you. Sridharan sir, thank you.
Thank you. Bye.
Thank you, sir. Thank you.